Today we're going to be talking about how to output or format your output, whether it be to the console or to a file, and then how you can read character input, which is to read a single character at a time, which you sometimes need if you want to, for example, be able to read names that have spaces between them. So we're going to start with output formatting and the member functions that you can use to control what kind of formatting occurs. And you've already actually used some of the member functions with cout this semester. So you may remember this magic formula for printing floating point numbers to 2 decimal points. You are actually using methods that manipulated the state information, the formatting state information for the cout stream. setf allowed you to both specify whether you were using fixed point or scientific notation, and then the show point parameter to setf allows you to manipulate whether you see a decimal point when a floating point number ends up as an integer. And then the precision method allows you to control the number of either decimal digits that get printed if you're in fixed point format, or if you're in scientific notation, it controls the number of total digits that get printed. And the OF stream class has functions with the exact same names and similar functionality, so if you're writing to a file, you can do exactly the same thing. So you've already seen the setf method, and remember that by default you actually see numbers printed in scientific notation, and if you want fixed point notation, then you have to specifically ask for it by saying cout.setf iosf fixed. And we've already gone over show point, but here's an example. If I set the floating point variable x to be 10 and print it out, if I don't do anything, it'll simply print out as an integer. And sometimes I really want to force a decimal point to print out, and I can do that by calling setf with the show point parameter or argument, and in that case it will print out to the number of decimal points or places that you'd normally do. Now in this case you see that it's printed to 4 decimal places. Well, I didn't use fixed, so what's happening is it's actually using scientific notation and printing 6 digits, and because 2 of them go before the decimal point, there's 4 left after the decimal point. And finally, as we've gone over in class, precision controls how many decimal places to output with fixed point numbers or how many total digits to output with scientific notation. And just as a reminder, if I'm in scientific notation and I set precision to be 2, and I try to output this number 1234 and change, what actually just gets printed is 1.2 exponent 03, because only the 2 most significant digits will get printed. The next function, and the first one you haven't seen so far for controlling the formatting of the output, is the width function. And it allows you to control the width of the field in which a value is printed. So here I'm asking for the next value to be printed in a field that is 7 characters wide. And when I print out 43, there's going to be 5 empty spaces. And as you can see down here with what is highlighted in red, it was indeed printed as 43, and there were 5 leading blank spaces, and the reason for the 5 leading blank spaces is the width was 7, there was only 2 spaces occupied, and it uses right justification by default. You have to get used to that because most of you will think it should be left justification, but it's not, it's right justification. Then I print out 43, and you'll notice that there's no empty spaces. That's where the green is, the second 43, and there was no leading 5 spaces, and you're like, well, I set the width to 7, Well, here's the important point. With applies only to the next item of output. It's the only non-persistent formatting function. So you have to repeat it each time that you print a value, or else it only, well, it always applies only to the next value that you print. Okay, and one thing that often trips up students is that if the value to be printed is wider than the field, the value is not truncated. It gets printed completely. If I had, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I was printing it out, it would not have gotten truncated. What you would have seen here is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when 43 got printed out, oh, it would not have been put there. What I need is 2 more columns. It would have printed as 43 right afterwards. So do not assume that you're going to get truncation if the value is greater than the or the width of the value is greater than the width of the field. Okay, as another example, let's say I printed out Michelle. Well, Michelle is 8 characters, as you can see. And it would print out M-I-C-H-E-L-L-E. And then it would print 4 and 3 right afterwards. So do not truncate, or do not think that C++ truncates values that are too wide. What the width field does is it gives you a way to line things up in nice even columns, and if your values aren't wide enough, it will put some either leading or trailing spaces in depending on whether the value is left or right justified. And it gives you a way, as I say, to line up your output and create nice even columns. Now the book shows you how to do left and right justification using the iOS setf and iOS left and iOS right flags. Don't do it this way. It turns out it does not work the way the book claims. It's confusing. If you want to set left and right justification, use the IO manipulators, which we're going to show you next. But first, just a couple examples. Let's tell you I want you to write a cout command to make the field width for the next output item be 10 spaces. The way I would do that is with the width, and that would make the output be 10 spaces wide. Okay? And if I wanted you to print decimal numbers with 4 decimal places, you've seen it already, but just to reiterate, you would first say it's fixed, then you would need to say show point, and finally the precision, which in this case is 4. And you could combine the cout with, so this would print it in a 10, the value in a field 10 characters wide with 4 digits of precision. Now it's often easier to use what we call IO manipulators, which are formatting commands that you can actually embed in the cout stream. And they're found in the IO manip library, so you need to make sure that you include it in your program. So now with the IO manipulators, you can just drop formatting commands directly into your cout statement. So here, set W is setting the width of the next, or the field that the next value is printed in, to be a width of 7, and prints out 43. And as you see over here in the blue, it's printed out with 5 leading white spaces. And then in green, I did set W 4, so the next value is printed out in the field of width 4, and since the value is 2, you get 3 leading blank white spaces there. Okay, and just like with, set W only affects the next item. So then there's also set precision, which allows you to set the precision of your output, and that is persistent. So once you say set precision 3, all further output will be printed to 3 decimal places unless you specify otherwise. And there's manipulators for left and right justification for specifying fixed point and show point. So here in this example, remember by default it's right justification. Normally we want to left justify our string, so oftentimes we want numbers to be right justified, but usually strings are left justified. So here by specifying left before printing the value, it left justifies the value, and it's printed in a field of width 10, and because it's now left justified, there would be 6 trailing spaces. Here, we actually, in order to ensure that the number is printed out to just 2 decimal places, we dropped in the fixed and show point commands and then said set precision. It's usually a good idea to include these with your cout statements, even if you could just do it once. You could have just said at the beginning of your program, you could have just said cout fixed show point, and you wouldn't have to do anything else. But it's better, in my opinion, to do it each time, just to ensure that if someone changed it in the meantime to scientific notation, that you're changing it back. Okay, so another demo. Let's say that we're printing out 23 and we're doing it with left justification in a field of width 5. What gets printed out is 2, a 3, and then 3 blank spaces. So the next value, whatever it would be, would start in this blue, would start right here. Whoops. Okay, I'll have to, it would be printed in the remaining things, but there would be these 3 trailing spaces that you see right here. Okay, now what I want to do is I want to write a statement that is going to print an int variable out, and it's named count, and I want to print it in a field of 10 positions, so I would say cout set w10 and then count. And I didn't say anything about left justification, so by default it's right justification. However, if that previous statement with cout left had been executed and I really did want it to be right justified, I would have to add it right here. And finally, I'm given 3 variables k, m, and n. They're all ints, and I want to print each of them in a 9 character wide field. So if I had 27, this huge number, and minus 4321, 27 would get printed with 7 leading spaces. Notice that 987654321, it gets printed, it takes up the entire field, and then minus 4321 takes up 5 spaces, so there are 4 leading blanks. And my statement for doing that is going to be cout set w9 k. Now, if I just said m and n, it would not do the right thing because the set w9 applied only to k. So I actually have to say set w9 again, and again after the m. Now, this can get awfully long, and it turns out it's quite okay to break lines. So I could just write it like this, and then it looks a little bit easier to read because you can see how each value is getting formatted. IO streams can be passed as parameters to function. They must be passed using call by reference. So here's an example with copy. I'm passing both a ifstream object and an ofstream object. You must pass them by reference. and G++ will complain if you do not pass a stream by reference. Some compilers aren't as accommodating, and then you can get funny results. So it's just something you need to memorize. Okay, so here's an example where I'm printing a file. I'll assume that I've already opened this IF stream and that now I passed it as a parameter to print file, and I'm just reading through the words in the file and printing them out, each on a separate line. So define my variable for holding my words. Then while I have another word, remember that the input operator returns false when it hits end of file, but as long as we successfully read a word, we then print it out. So that takes care of formatting and brings us to the last topic with IO streams, and that's character input. And you'll notice that up to now we've only been able to read one-word strings, but you can imagine that'd be pretty limiting if a computer could only read one-word strings. It might want to be able to read multi-word strings like a person's name, and that person's name, in this case Brad Vanderzanden, includes 2 spaces. And it doesn't work to use the input operator because the input operator stops reading a value as soon as it sees a white space character, which is defined as a space, a tab character, or a new line character. And the operator will read up to that white space character and then discard it. So if I try to read the string Brad Vanderzanden, all I get is Brad, and then the next time I used it I would get Vanderzanden, and the third time I used it I'd get Zanden. So delimiters are very important. It tells C++ where or how far to read and where a value ends. So as I said, the input operator treats a space, the tab character, and the new line character as delimiters. But you might want to use other delimiters. So there's a format used by spreadsheets called comma-separated values, CSV, and it separates each item with a comma. So here you see a comma. I have an address, and I have a street address, then I have my name of my city in a comma, then I have the state, and finally the zip code. And actually the zip code, then we'd have a \n. So in this case we really would not want to use the input operator to read it because it would stop at 1678, then at Cardiff, then it would read wrote as RD period comma new because there's no space in there, and so it would read this whole chunk, and that's not what we want. So we're clearly going to have to do something else if we want to use commas as delimiters. And just as another example of a delimiter you might use, here's one with asterisks where I separated the values with asterisks rather than commas. So it's quite common to want to use delimiters, and in order to use a delimiter other than the space character, we have to use the get method that's associated with streams. And that get method will read a single character at a time, and then we're going to be responsible for checking to see when we reach the delimiter character that we're interested in. So just as a simple example of get, here's some code that just reads a single character. We define or declare the variable c as a char, call cin.get, and get reads the next character in the input into C. And C is a by reference, or the parameter is a by reference parameter because C gets all. So if the input is 124 space Brad, C will end up with the value 1 because that's the first character in the input. If then I said cin.getC again, now C would equals 2 because that would be the next character, then cin.get, and C would now equal 4, and finally cin.get, and C would equal the space character because spaces are not ignored in this scenario. Instead, they're read just like every other character. So here's a longer example where I'm going to use the getMember function to help me accumulate a name such as Brad Vanderzanden. I'm going to assume that each line starts with a score followed by a blank space, then a name, and is terminated with the new line character. And again, you don't see the new line character in your input, but when you hit the return key, that generates a new line character. So we set the name, which is my name variable, to the empty string, read score. Now, the input operator leaves this space between 3 and the B in the input. It doesn't actually read it. So the first thing we want to do is gobble up that space like Pac-Man because we don't want it as part of our name. So then we read the first character in our name. That's our priming read. And C should now be equal to that capital B. And now while the character is not the new line character, so the new line character is now our delimiter. Okay, it's what terminates the name. We're simply going to concatenate our character to the end of name. Remember that when plus is used with the string variable, that it means concatenation. Then we get the next character. So this will read all the characters from capital B up to N and concatenate them to the end of name. So I'll end up with Brad Vanderzanden. Eventually, this \n gets read, and we'll see then that C is equal to it, and we will exit our loop and properly print out the score and the name. And if there are multiple lines in this file, we could have an outer loop that would then start reading the next line, and we would be perfectly set up to read the next score because we just gobbled up this \n character. Okay. So the last thing, just quickly, some useful functions. We won't use them a lot in this course, but you should be aware of them. Is that C++ defines a number of predefined functions to facilitate working with characters, and they're found in the C-type library for C character type. So if you want to use them, you need to include that library. So there are functions to convert characters to uppercase. So sometimes you'd like everything to be uppercase, and that's the toUpper function. And if it's a lowercase character, it returns its uppercase equivalent. If it's already uppercase, it does nothing, simply returns it. And similarly, we can have an argument toLower that returns the lowercase version of a character. So that can be useful when the user enters input like yes, and we're not sure if they're going to enter the input as yes, or maybe they'll enter it as yes, or all caps, and by either setting everything to lowercase or everything to uppercase, it doesn't matter how they entered it, we'll end up with a consistent representation for that input value. Okay, if we're want to check for lowercase, there's a Boolean function called isLower, and it returns true if the character is a lowercase letter and false if it's an uppercase. Similarly, there's one called isUpper that returns true if it's an uppercase character and false otherwise. And then there's some functions for checking the type of a character. So if we want to know if we read a letter of the alphabet, we can call the isAlpha, and it returns true if we read either a lower or uppercase letter. If we want to know if we read a digit from 0 to 9, we can call the isDigit function. If we want to know if we read white space, then we should call isSpace, and that will return true not only for the space character, but also for the tab character, the new line character, and a couple other characters that you don't need to care about at this point.